Fractional powers then. Well, the only one we really worry about is the square root. So we just look at this particular one, it's a power of a half. Now, anywhere where the original graph is negative, basically those x values disappear because you can't find the square root of a negative number. So in a lot of these graphs, a whole heap of it will just disappear. Okay. So it's only defined if the original function was greater than or equal to 0. Here's random graph. As far as we're concerned, that's the original graph, because I only want ones where function value is greater than or equal to 0. Okay. It's always going to be positive because we're looking for the positive square root. So the answer is always going to be positive. Now, square root of function x will be less than the original graph if the function value is 1. So it's like the opposite of what we just did. You find the square root of a number bigger than 1, it's going to become smaller. So it'll be below the original graph. But if you find the square root of a number smaller than 1, it gets bigger. So it'll be above the original graph. So 1, yet again, becomes a very important point because the square root of 1 is 1. So we know they're going to remain. This time I'm finding the square root for the horizontal asymptote, but it's smaller than 1, square root of a number smaller than 1, so it's going to rise. So I've moved it up a bit. Vertical asymptote, that's going to stay the same. Here's the derivative. If I differentiate the square root of function x, I get f dash x over the square root of function x. So original stationary points would have been where the derivative was equal to 0. So in this new derivative, it's still going to be 0. Okay. But now we have the square root of function x on the bottom. So originally where we had x-intercepts, the derivative is undefined. So that doesn't mean the function's undefined, it means the derivative. So we're going to have a vertical tangent. Or we might end up with a cusp, right? Or a V shape like an absolute value. So we can't differentiate it at that point. So I guess it all depends on the domain. Now, think about what the original graph is. If you know its function, it makes life easy because you can say, oh, square root of that. So if you knew the original function was x to the power of 4, then you know the square root of x to the power of 4 is x squared. So you'd have a turning point. So if it was x to the 4, it would have been flatter at the base. When I find its square roots, then it becomes like a parabola. X cubed, though, can't find the square root of a negative number, so the left-hand side disappeared. And you just got that bit up there. X squared, so if it's a parabola, find the square root of x squared, you're going to get an absolute value sign, because it's going to be a linear function when you find the square root of a quadratic function. Then you get fractional ones, 5/3. If you're unsure, you've got to maybe plot some points if you've got the function. Right? If you don't know, so like mine's just a random graph, then you sort of explain yourself. And you go, well, look, I think this looks parabolic, so I think it's like a quadratic function, therefore I think it'll come in. As long as you explain what you're doing, it's going to be okay. You might not get the original thing that they were intending, but if it's just a random graph where you don't know the function, as long as you explain why you've come up with the conclusion and it's valid, then you should be fine. So right, on my one, it looks like the original graph was cutting through like a single root. So if it was a single root, it would have been a linear function. And if I was to draw the square root, then I would have got a parabola on its side. So I'd get that vertical tangent. So I'm thinking some sort of vertical tangent there. I'll just plot some points in here. Our stationary point up here will come lower because we're finding the square root of a number bigger than 1. Let's try and draw it in. Yeah, it's real dodgy. I might have exaggerated my vertical tangent a little bit here. It sort of went, but look at that. A thing of beauty. That one there, if I was to write it down, I'd say, look, out at our x approaches infinity, the original graph was approaching y equals some constant value that was smaller than 1. Therefore, this one should approach some square root of that constant, or something like that. Right? Now, if I wanted to draw y squared equals function x, instead of y equals the square root of function x, there's a little bit of a difference. Because now y can be negative. Watch this. It reflects in the x-axis. Because essentially what you're saying, when you said y squared equals function x, you're saying y equals plus or minus the square root of function x. And so you get that reflection in.